if you go back to your earlier studies in calculus, you recall that to find that this green area region where it's bounded between two functions of x from some point A and some point B, where x equals A and x equals B, the way that we could do this and solve this was by letting the area equal the integral from A to B of the top function subtracting the bottom function, right? So you're basically finding the area all the way from 0 to the top, and you're subtracting the area all the way from 0 to the lesser function. And you can, and this is just another way to represent that. But we can do the same thing using an iterated integral. We can say, okay, instead, we're going to let x go from A to B, and the value of y is going to go from this function to this function. At each individual's time, whatever the x value is, y is going to go from whatever that function value is to whatever that function value is. And we're just going to integrate, really, you could think of this as 1 times that. There's I'm not going to get into particulars, but usually when we think of a double integral, you're actually doing like a volume instead of an area. So if the height of something is always 1, then the area is equal to the volume in magnitude, not necessarily in units. But it's kind of a small little particular there. And the reason I'm saying that is because double integrals, just like single integral or standard integrals, lend themselves very well to thinking about area. Double integrals lend themselves really well to thinking about volume. So I'm kind of trying to set that up. But if we want to take a look at a simple case of doing that, let's just take a look at a rectangle. In this particular case, the functions are just constant functions. They always have the same value. So we go from the lower function c to the higher function d, and we're going from x value of a to x value of b. So integrating here, well, the integral of dy is just y, and y goes from c to d. So that's like saying d minus c. And then we integrate with respect to x. Well, that's just a constant, so it's d minus c times x from a to b. Well, it's basically the x value is b minus a. So we have the difference, basically the length of this rectangle, and this distance, which is the height of that rectangle, and obviously the area of a rectangle is base times height. So this is just a simple case. We're obviously going to get much more complicated with it, but this is to try to give you an idea of how we're going to get started and where we're going to go.